Thank you. Good afternoon, ladies and gentlemen. It's my great honor to be here, and I'm very grateful to Professor Ganoa and the ICT to give me the opportunity to talk to you. This is great. So I am a technologist. What we do is we turn lights into communication devices. I know many of you have various different challenges in the space of security, cybersecurity, enhancement of battlefield communication, and efficiency there. I don't know all these different requirements, but I think the technology that we have developed can address some of these individual challenges. So what we do is to turn these lights, not these ones because they're not LEDs, but LED lights into high-speed communication devices so that you can communicate and illuminate. You may wonder, why is that important? I'll tell you in a minute why it's important in the context of this conference. But before I start giving you some ideas how and why it can be used and how it can address sort of the technology innovation in the space of countering terrorism, enhancing security, I have brought with me a little video that gives you the idea what we do.
This is the world's first LiFi system. The LiFi offers high-speed, bidirectional, visible light connectivity. The system consists of a ceiling unit that...
Sorry, was me. Apologies.
This is the world's first LiFi system. The LiFi offers high-speed, bidirectional, visible light connectivity. The system consists of a ceiling unit that connects to a standard off-the-shelf LED light bulb and a desktop unit that connects to the laptop via a standard USB connection. The ceiling unit has an Ethernet and power input. It connects to the LED luminaire and modulates the visible light for the downlink. The desktop unit has a visible light receiver and an infrared diode for the uplink transmission. The system operates at 5 megabit per second in full duplex at distances of at least 3 to 5 meters. The distance and data rate depends on the particular LED luminaire that is used. The key IP of pure LiFi is the optimal utilization of the optical bandwidth. The sensitivity of the desktop unit means that the system functions with direct or indirect light. This sensitivity means we can dim the light to very low levels without greatly affecting the performance of our system. As you can see, the system is still transmitting at high speeds and streaming the video. The LiFi is just a sample of what pure LiFi products will offer in the future.
So that hopefully gave you an idea what a LiFi is. Now I'll tell you a little bit how it can be used in the context of security. First of all, light has particular properties. Light doesn't penetrate walls. Radio does penetrate walls, and therefore it can be intercepted outside a room. In a room like this, light wouldn't be interceptable outside. That's very important in industries like banks, company headquarters, where you don't want to have eavesdropping of information leakage. And then you have environments which are intrinsically safe, for example, petrochemical plants, magazines in critical environments, where the antenna of a radio system can create explosions, can create sparks, and these sparks can cause explosions. Light wouldn't be vulnerable for that kind of risk. Furthermore, we have many light sources, as you see here, and these light sources are allow very localized information. It allows the tracking of people inside the room and also allows asset tracking within these spaces, for example, assets like files and documents. And what is also important is, as you see in that room, we have many, many light sources, as you have here. And if you assume that a light source has the same capacity as a typical Wi-Fi router, now you see we have not one Wi-Fi router, we have 50 to 100 light sources. And that means you have 50 to 100 times higher data capability in an environment like this, giving you new opportunities to convey and change information. So what we really want to talk to you is the application of that technology in the space of secure communications. I would like to state at that point that information is key. And it is very important that wireless communication and the exchange of information is enhancing efficiency, productivity in spaces like battlegrounds, battlefields, but also the availability of information in these environments enhances the effectiveness of missions. Radio, as I said, should be used, but radio allows others, enemies, to eavesdrop the signal and eavesdrop the information, and therefore often it is disallowed. And what we really like to do is we would like to combine the advantages of mobile communication, the distribution, dissemination of information in a very rapid and speedy context manner, with the security, inherent security of wired communication. And LiFi and light communication allows this combination. So let me explain a little bit what the vulnerability of radio communication is. If you consider a radio system like your Wi-Fi access point, the antenna is a transmitter, and that transmitter usually transmits the signal in all directions, 360 degrees. Even if your antennas, as shown here in that diagram, which try to point the transmission in a certain direction, you have something like these little hubs here. These are side lobes. So an enemy would be able to eavesdrop the signal, even if it's not in the direction of the intended beam, even if it's here, would be able to eavesdrop the signal and interfere with that communication link. Therefore, that poses a big security risk. On the other hand, if you look at a light beam like this, it is possible to concentrate the information very concisely within such a beam, and the signal falls off very rapidly outside that light beam. And that creates secure wireless connectivity that cannot be or can hardly be jammed as well. And I'll come to that later. Now, how do we apply that, and how can we apply it? We have looked at, for example, underwater communication. Look at submarines. So if you have a submarine and a submarine wants to exchange information with a vessel on the surface, usually it has to surface, or it has to put an antenna out to the surface, which is an omnidirectional transmitter, and the signals can be intercepted by the enemy. And a surfacing submarine also is vulnerable. So what could be done is you have a vessel on the surface that puts an umbilical cord with a light source attached to it down to the submarine. And that umbilical cord with a light source conveys and transmits to the submarine, then exchanging vital information in the mission. That does not provide a great security risk. And also, if you think of divers underwater, a diver mission, usually what divers use is acoustic signals to transmit information, exchange information. These acoustic signals are typically low bandwidth, low data rate, and also can be heard far away from the diver. So they pose a security vulnerability. But what the divers could use is their torches. They could use their torches to exchange information in a way that it cannot be intercepted because it's very directional and also over low distances, but also at very, very high speeds. If we move further to battlefield missions, where soldiers typically like to be equipped with wireless technology in order to optimize the mission, That's what we learn from talking to people who provide equipment. Again, the radio provides, because of the fact it can be eavesdropped, a risk. But the directionality of a light source and the fact that we can dim the lights that it would appear to be off, but still would be able to transmit data, would provide a very secure means of transmitting information, videos, images of the environment between soldiers, or between vehicles. So you see the vehicles here, and the front lights of the vehicles could be the data transmitting source, transmitting to the vehicle in front. And again, this is very directional transmission, can't hardly be intercepted. But perhaps more importantly, if you look at current practices in battlefields, is that the enemy always tries, or sometimes tries to jam the radio signals and using the same radio frequencies. And that's fairly easy to jam a signal. You just have to put up antennas. And these antennas would basically cause disturbances. Now, if you think of using light sources for communication that are very directional, first of all, you would have to point with a very high power light beam into the receiver of your device. Not only that it's hard to basically find the right angle, it is also exposing the enemy, because you would see the light source and you would see therefore where the signal is coming from, and that he would disclose himself. Moreover, if you turn it around, if you are in a battlefield situation and you want to jam the signal of the enemy, you would transmit in the radio frequencies that you want to communicate as well. So you jam your own signal. But providing this additional link, light link, would give you another channel to do sort of the useful communication while you accept that your own signal is jammed. That's another way we can use the technology. Now think of operational theaters on the battlefield, which is shown on the right bottom here. These need to be deployed very rapidly, and installing lots of cables in these operational theaters in order to connect all these computers and monitors will take a lot of time, a lot of effort, and it also costs a lot of money. But you have lights, you have to have lights in these operational theaters, and the lights could be the sources of illumination, but also sources of data transmitters in order to quickly exchange a large number or a big amount of information within these missions. Now, moving on, going to Air Force and Navy, a submarine is a big tube of metal. It's a big, huge antenna. Therefore, radio signals can't be used inside a submarine, but you have many people inside that very crowded environment that would like to communicate lots of information and videos and so on within that environment. And also there's plenty of light sources in a submarine, which could be sort of the access points in that environment. Also, when you look at highly sensitive areas like the magazine of a warship like this, the antenna of a radio could spark explosions, and therefore you don't want to use radio in these sensitive environments. But the light sources could be used as a wireless transmitter, and it could also be used to track the assets, like the munition in that environment, to better control what is available or not available. Then if you look into the upper right corner, the helicopters, we understand that these missions where the crew internally, they still use pen and paper in order to develop the fine-grained strategy of the mission. So while the helicopter gets the signal from the satellite, the fine details will be agreed among staff on the plane in a very ad hoc and very timely manner before the mission starts. And now imagine you had a light source, or you have light sources in a helicopter where these light sources provide the crew for means to exchange videos about the environment, about the enemy in a very rapid way. The efficiency of a mission like this could be greatly enhanced. Moreover, if you look at the vessels, the ships down there, these vessels usually want to communicate in a very efficient and secure manner. Radio, again, provides the eavesdropping problem, But pointed light sources would be able to exchange, with pointed light sources would be able to exchange information in a very secure and in a way that it cannot be eavesdropped. The same applies to drones or vehicles that fly that could use lasers, but lasers require very fine adjustment. With light sources that we think of, these fine adjustments are not necessary, while the aircraft could still exchange images, videos of the environment. So, coming to the next application, which is, I think, one of the most important ones, is the application in indoor secure environments for indoor communication. And we believe that light communication provides a 5-tier layer of security, where the first layer is the fact that light doesn't penetrate walls. The second layer is that we have many light sources inside the room, and it would be possible to create and partition a wireless network so that it is possible to track movement, track assets. Also, the light sources itself could provide a hardware encryption key in order to provide not only username, password, but you would also have to provide sort of the individual key of that particular light source you'd like to communicate as a third layer of security. And then it would be possible to trace people moving in a room like this, that I started at some time communicating to that light source, but sometime later I communicate to that light source. It's possible to track the movement and give users access on a certain trajectory, a certain path through the office, and also allow a fence, a number of light sources around it to be able to communicate as well and give access to the same user. That's the fourth layer, and the fifth layer is the most important one because the weakest link is the human itself. But being able to trace assets inside a room and trace people, it would be possible to create behavioral patterns so that we know that some person at some time accessed certain files, but then there's an anomaly that on a Sunday, suddenly the file in a server room was accessed. And that is possible with that technology, and I will go into more details in these 5 layers in a workshop tomorrow. These 5 layers of additional security, in our views, are important for all secret service organizations, for governmental buildings organizations, but also for companies. And again, they are important for operational theater, where decisions are made where decisions require accurate information and also information of high quality. So, to summarize, I think the technology that I've presented provides great advantages, as I've shown in military, in defense, like underwater communication, in battlefield communication, aerial, naval communication, and secure indoor communication. One of my last slide, what I would like to tell you here is that you may wonder now, yes, this is all nice and good, but I haven't seen any of these devices in operation. Do they exist? So I've coined that term LiFi in my talk in 2011, and we have since sort of spun out a company that's called Pure LiFi, where we have developed that communication technology and have shipped it to various industry, but our experience so far is that we believe we can serve immediate needs in the defense and security industry. What we do is we develop a diverse but aligned ecosystem of partners with whom we would like to further develop applications around that technology. So what we'd like to do essentially is we'd like to serve the desire of ever more secure wireless communications in that particular industry, and I'd like to talk to anyone who has been interested. Thank you very much.